For most of human history, the sky changed slowly. Stars appeared fixed, planets moved predictably, and anything small, dark, or distant passed unnoticed. If an object crossed the solar system 100 years ago, chances are no one ever knew it was there. That reality no longer exists. We are now entering a new era of detection, an era where the sky is monitored constantly, automatically, and in unprecedented detail. Modern survey telescopes scan the heavens every single night, comparing images, tracking motion, and flagging anything that does not belong. And because of that, we are discovering more objects than ever before. Asteroids, comets, near-Earth objects, and increasingly, objects with strange or extreme orbits that challenge our first interpretations. This technological leap is powerful, but it comes with a cost. Detection is becoming faster than understanding. When a new object is discovered, scientists often have only hours or days of data, a short observational arc, a handful of measurements. From this limited information, an initial orbit must be calculated. And in those early moments, uncertainty dominates. Small errors in position or velocity can dramatically alter the result. An orbit that looks hyperbolic may later become elliptical. An object that seems unbound may turn out to be firmly tied to the sun. This is not a failure of science, it is a consequence of speed. Systems like Atlas, Pan-STARRS, and soon the Vera Rubin Observatory are designed to prioritize detection over certainty. Their mission is to find everything first. Understanding comes later. Refinement takes time. Confirmation requires patience. This is why cases like Oumuamua, Borisov, and 3I Atlas are not anomalies. They are previews. They represent the growing pains of a scientific transition where our observational power has outpaced our ability to immediately explain what we see. In this environment, borderline cases will become common. Objects from the Oort cloud will be mistaken for interstellar visitors. Interstellar objects may initially look ordinary, and public interpretations will often move faster than scientific consensus. This creates a dangerous gap. A gap between discovery and confirmation, between headlines and data, between what appears extraordinary and what is eventually understood. And that gap is fertile ground for confusion. In the coming years, astronomers expect to detect tens of thousands of new objects annually. Many will have unusual inclinations, extreme velocities, or trajectories never observed before. Each one will briefly exist in a state of ambiguity. Some will be mundane, some will be misunderstood, and a few may truly be unprecedented. The challenge will not be finding strange objects. The challenge will be knowing which ones deserve extraordinary explanations. This new era forces a shift in mindset. Instead of asking, "Is this object impossible?" scientists must increasingly ask, "How incomplete is our data right now?" Because the more we observe, the more we realize how much context is missing in the earliest moments of discovery. A single night of observations can never tell the full story of an object that has traveled for billions of years, and this problem will only grow. As detection systems become more sensitive, they will begin identifying objects farther away, smaller in size, and moving faster than anything previously cataloged. Many will be detected only briefly before fading from view. Some will be lost entirely before their orbits can be fully resolved. These partial discoveries will test not only our models, but our discipline. The temptation to label something as extraordinary will always be strong. Headlines will demand certainty. Audiences will demand answers. But science advances slowly, even when discovery happens at machine speed. 3I Atlas was a perfect example. It was not extraordinary because of what it turned out to be, but because of how easily it could have been misclassified. Its brief moment of ambiguity revealed a future where such moments will be routine rather than rare. In this future, patience becomes as important as curiosity. Certainty will take time. Orbits will evolve, interpretations will change, and first impressions will often be wrong. This may feel uncomfortable, especially in an age that demands instant conclusions, but it is not a crisis. It is progress. For the first time, humanity is no longer limited by blindness. We are limited by interpretation. And that is a far better problem to have. As our instruments continue to improve, one outcome is inevitable. More objects will challenge our assumptions. More discoveries will blur old categories, and more questions will arise long before answers are ready. The universe has not suddenly become stranger. We have simply become better at noticing it. And in this new era of detection, the greatest mystery may not be what we find, but whether we are prepared to understand it with the patience, restraint, and humility it demands.